These applications. Auditorium has 20 seats on the first row, 24 in the second. It doesn't take long for you to understand that there is a D value of 4 for this problem. The first term is 20. Now let's just make sure we're answering the questions appropriately. It has 30 rows of seats. That's important information. How many seats are in the 26th row? Okay, so what do we got? We got our formula that looks like this. Now, how did I know to go to this? Because this is not a summation formula. This is literally just figuring out a certain term of an arithmetic sequence. So if I wanted to find the 26th row, I would just do this. Since they gave me the first row of 20, I would have a 25 right here because of the n value being 26, and then I would multiply by the 4. So we can clearly see that 100 plus 20, you will have 120 seats in the 26th row. All right, well, totally different question. When we ask you how many seats are in the theater, okay, or the auditorium, maybe I should have stayed consistent with that. So in the auditorium, would actually be summing them all together now. So what I want to do is I want to sum up how many. Well, there's 30 rows of seats. So sum up the first 30 rows. So then that would be 30 over 2. I'll take twice my first term, which was 20. I'll add to that n minus 1, which is 29 because of the 30. And then my D value is still 4. So I got all my goods there. It's just a different question. I got to make sure I'm answering it appropriately. So what do we got here? 30 times 4 would be 120. Back off. So we got 116 plus 40. So 156 times 30 divided by 2. I struggled there. Okay, so did I say 116 plus 40? So 156 times 30 equals that, divided by 2. And there's 2,340 seats in the theater, the auditorium. All right. All right, moving along here. Suppose you go to work for a company. 1 penny. I'd like to find a company that does this, but 1 penny a day. So the first day, boom, a penny. So 0.01. The second day, boom, what? 2 cents. Third term, third day, boom, 0.04 cents. So you clearly see that the R value is 2. We are doubling our pay every single day. Okay, if the daily wage keeps doubling, how much will you make on the 31st day? Well, that's fun. So it's a it's a geometric one this time. So you have to follow this formula, R to the n minus 1. Well, if we wanted to find the 31st day, what we do is we take the first term, which we have as 0.01, and then we have an R value that is 2. And then we raise it to the n minus 1, so that would be to the 30th power. So, pulling up the calculator here, we have 2. And we raise it to the 30 power. Have that, wow, times 0.01. Still going to be a lot of money. So what do we got? I'm going to go up and bring that down. And I'm going to try to read those numbers. 1073741.8 I believe 24. I hope that's correct. Let me see real quick. 3741824. I think that's what I just wrote. Yep. So that would be a good old 10 million. 10 million on the 31st day. Yeah, that's a pretty good company for a month's worth of work. How did I just do this? There we go. Okay, and then there's another question, I think. How much will you make in all? So again, sum up the first 31 days. And what will that be? Okay, that will be the first term, which is 0.01. And using our formula, 1 minus r, which is 2, raised to the r, which is 31, all over 1 minus r. So when we fire that into our calculator, get this in here, we're going to get control divide here, 1 minus obviously even more money. 2147.4836.47. So 3 decimals. Wait, 3 decimals. I put that on the wrong spot. So 3 decimals, and it comes out to 21,474,800, and a lot of money. Okay, so that's how you do that problem now. All right, so a tube well is bored 800 meters deep. The first meter costs $250. So realize the first meter that we have charged costs $250. All right. Increases by 50 every time. So basically the second meter is going to cost $300, the third meter is going to cost $350, and so on and so forth. Okay, so we're going to do this all the way for 800 meters. Okay, so $250 and adding 50. So that would be an arithmetic with a D value of 50. All right, so I think find the cost of the 750th meter. So again, using our formula, we got 750, the 750th term here, and then that would equal the formula basically is the first term, which is 250, plus, and then n minus 1 would be 749 for that, and then times my D value, which would be 50. Okay? So all you gotta do is crank out the calculation and you will find out how much that costs. So let's do that too. I don't know why that keeps happening. Okay, 250, and I'm gonna add 749 times 50. All right, so 37,700. I think what I got, 250 plus 749 times 50. Yep. Okay, so that is, so understand what that is in the context of this problem. Be like, all right, $37,000. That is for the 750th meter. Like this is for 1 meter. That 750th meter out of all 800. So then the next question says the total cost incurred. So that means the sum of all 800 meters. Well, 800 divided by 2 is my 400. So then I have 2 times my first term. So that's going to be 500 plus n minus 1. So that'll be 799. And that would be times my D value, which is 50. So using those summation formulas that we have there, I want you to see what this number would be. It's pretty intense. 799 times 50 equals that, plus 500 equals that, times 400. And then there we are. Okay, so what do we got here? We got 1618, and then 1, 2, 3, 4 zeros, I believe. Make sure on that so I can see it. Yeah, 1, 2, 3, 4 zeros. Cool. 1, 2, 3, 4 zeros. So boom, and 1, 2, 3, boom. $16 million project. $16 million project. All right. Sounds like a bore. Like a bore. Okay. Anyways, moving along. What do we got here? Sunny has 101 blocks. Well, I think I forgot to tell you guys this. I hope I didn't, but it's supposed to be 105 for this problem to work out nicely. Otherwise, the blocks don't come out to a whole amount, which won't work. So I'm sorry about that, but now that you know that, hopefully maybe you can try the problem, pause, the video, try the problem, and then see if you get it right. All right, but she wants to stack up all the blocks. There's one block on top. I like to think about it as one block on top. Each row has one less block than the row below, so 2 blocks, then 3 blocks, then 4. I mean, obviously this is an arithmetic sequence with a D value of 1, and she's got 105 blocks in total. Okay, so how many rows should she put on the bottom row? Well, the bottom row is obviously going to be the nth term in our sequence, the last term in our sequence. So this is an arithmetic sequence, okay? And we could basically go through this problem, but we do need to know something about the summation because she has 105 blocks. I mean, that's the idea. So it's, you could obviously play this one out just by drawing it out and thinking it out, but we want to talk about doing this problem as if that number of blocks was a really large number. So what do we got here? We got this, and we got 2 times the first term. Well, 2 times 1 is 2. Plus, we don't know the n right now, so n minus 1, and we do know the d is 1. So you can see how simple this formula works out to. We do have 105 blocks. So that basically turns into 105. And then we've got n over 2 times, well, when that distributes through, we'll have 2 plus n minus 1. And then we'll have 105 equals, and then I can just keep it like this. 2 minus 1 is 1 plus n. Multiple ways I can do this. I like to multiply both sides by 2 to get 210 equals n times 1 plus n. And then we got 210 equals n plus n squared. And then we've done this 400 times this year, right? So n squared plus n minus 210 equals 0. And let's not kid ourselves. If you, sorry, it's a plus sign right there. I just wrote it poorly. That says n squared plus n. It's not a very good plus sign there. N squared plus n. If you don't like trying to come up with factors that are close together for 210 or whatever, you can go to your calculator for that, remember? So it doesn't take long on here. So you go to menu algebra, and then you go to your poly tools, and then find roots. They're going to ask you, is that what you want to do? And if you fire in a 1, and then you fire in a 1, and then you fire in a negative 210, whoops, and then you fire in a negative 210, and then you hit OK, and then you hit enter, it'll do it for you. So it comes out to negative, the n values come out to negative 15 and 14, which we clearly don't have negative blocks in a row. So this just meant the n value is 14. So I want you to think about that. If the n value is 14, that means the 14th row was the one that was the last row. Well, each row had the same number of blocks in it as the term number. So, the first term had 1 block, second term had 2 blocks. So obviously the 14th row would have 14 blocks. So we'd have 14 blocks in that one.